So I'm starting with the basic definition of a vectors. In physics, definitely you might have studied about the quantities vectors and scalars. Vectors and scalars basically are in which we can categorize particular quantity. Say for example, if I talk about the mass, or if I talk about the distance, displacement. Now I have to find whether this particular quantity is vector or scalar. So for that, I should know what exactly vector and scalars are. So vectors are basically those quantities that have magnitude as well as the direction, whereas scalars are those quantities that have only direction. That means it has it has only magnitude. Scalars have only magnitude, whereas vectors have magnitude and directions. Hello. You all can mute yourself, okay? Mhm. Okay. So basically, I was saying that vectors are those quantities that have magnitude and direction, and scalars have those that are just having the magnitude. Magnitude, that means the value, just the value. If I say mass, 5 kg, 5 kg signifies its value. That, okay, that particular thing is of 5 kg. Distance, that means 4 meter, particular or 7 kilometers. So that is the magnitude or the value. And direction, we know that I can write east, west, north, south. This is direction. Now I have to see whether the quantity can be specified as vector or scalar. If I talk about the mass, I cannot say that my weight is 5 kg downwards, 5 kg upwards, left side, east, west. Obviously, we never specify direction for that. And this is the reason that scalars are, mass is categorized as scalar quantity. Distance, if suppose this is the point A and point B. Definitely to move from point A to point B, I have infinite paths. I can move like this, I can move like this, I can move like this. Suppose I have chosen this path. And somebody asked me how much distance you have traveled. I can say I traveled 3 kilometers. But can I specify my direction? Obviously not, because there is no particular direction in that case. I cannot specify my direction. I can only specify my value, my magnitude. And that's why distance is also categorized as scalar quantity. Now comes the displacement. Displacement is something which we can say the shortest distance. In physics, we can say it's the shortest distance. Or in general language, we say how much I have displaced myself, right? So that means my main aim is to find the initial position and the final position. Doesn't matter how I reach there, only the distance between the initial and the final position. So taking the same case A and B, if I want to know my shortest distance, that will be this. This is straight line. That is my shortest distance. And if this is my shortest distance, that means I can say I can specify my direction as well in that case. How can I specify my direction? I can say I have moved suppose 2 kilometers, right? And this was my initial position. This was my final position. So I have moved towards east, 2 kilometers east. In this case, I'll be able to specify my direction as well as my magnitude. So I can say displacement is a vector quantity. Is it clear to everyone? You can write yes, and if it's not, you can write no in chat section. Just quickly type yes or no. Okay, very good. Now note it down. Just quickly either note it down or take a screenshot. Okay, I'm just giving a minute. Okay. Now let me see how can we write or draw vector in mathematics. This was all about the basic definitions that we generally study in physics. But how we do vectors in maths? Let me see that. So in mathematics, a vector is represented with, if it's with the help of diagram, you have to draw a straight line and you have to specify the direction as well. Because this line is denoting your magnitude, the value. Suppose I want to specify 3 kilometers. So this whole thing is 3. And it's telling me that this is moving from this end to this end. So this arrow is giving me the direction. So this is a vector representation by a line segment. So vector representation by a line segment. There's another way by which we can describe the vectors that's in a written form, which is, suppose this is A and B, and if I want to write it, I will say A to B, vector A to B, and there will be an arrow above it which specifies the direction, and it is telling me that vector is moving from A to B. That's why it started from A and moving towards B. So vector is moving, or the particular quantity is moving from A to B. Suppose this value is not 3, instead it's just A. So I can write vector A to B is small a. So in this way, this A is what? Your magnitude, and this above arrow is showing you the direction. So just by writing this A to B equals A, I can easily understand that value is A, small a, and the direction is, it is moving from A to B. So this is a vector notation or vector representation when you write it down. So there are actually three ways by which you can represent or write a vector depending upon the question or the situation. When you're drawing, this is the first way to denote it. On, like, when you write it generally, and when you have to specify the coordinates specifically, like where in the space that particular vector is moving. See, in this case I'm not able to identify from where to where it's moving. From here also I'm not able to get to know. But when I represent a vector in a column form or in a matrix form, then I can easily get to know what coordinates are. Simple, vector is nothing. You have definitely studied the graphs. We know that this is x axis, this is y axis. On x axis, suppose it's 1, 2, 3, 4. This is 1, 2, 3, 4. If I pick this point is what? 1, comma 2. That means this point is where the value of x is 1 and the value of y is 2. In a coordinate form, I can write like this. Whenever I write like this, I can easily understand that okay, x is 1 and y is 2. So this gives me more detailed value that where exactly the point is. Now in vector form, if I say that one point is or vector always starts in mathematics, we think that vectors always starts from 0, comma 0. It starts moving. And now this vector is moving towards this. From here to here it's moving. So in a matrix form, I'll write 1, 2. That means here I'll write x coordinate and here I'll write y coordinate. So this gave me more detailed value that okay, my vector is actually at this point of time is at 1 comma 2 coordinate. That means it has moved 1 unit in x-axis and 2 units in y-axis. So this is a more detailed way of writing your vector. So in a matrix form, how we write? In matrix form, we write above the x coordinate and down below we write the y coordinate. So if it's 1 comma 2, I'll write 1 above there and 2 down there. So these are the three ways by which you can represent a vector. So just do let me know, is it clear or not? Just write down yes or no in chat section. Just be quick. You can write yes or no. If it's not clear, I can repeat once again. Okay, very good. Now just quickly take the screenshot or write it down. I'm just giving you 1 or 2 minutes for it. Okay, I'm just quickly repeating it once again. This There are three ways by which you can represent a vector. The first one is by line segment. This is by line segment. So you have to draw a line segment. This line represents the value of a vector because vectors can be represented by line segment as well as by direction. So this line segment represents the value, whereas this arrow represents the direction that vector is moving from A to B. The second is writing it down vector A to B. That means vector is moving from vector A to B. Same thing, the same line segment part I can write like this, that the value of vector A to B is A. So A, small letter a represents magnitude, whereas A to B represents its direction. There's an important thing, you can't do like this. Suppose I reverse the direction. Everyone, if I'm drawing this and now my vector is B, here same A to B, but I have reversed the direction. Magnitude is still A, but I have reversed the direction. It's now like this. So don't do like A to B and moving arrow in this direction. It's a wrong representation. Okay. Arrow always points towards in a forward direction. Your arrow should always be in this direction. This direction is incorrect. So if arrow is always in this direction, so I will write vector B to A, but arrow should always be lit. Letters gets interchanged, but arrow will always pointing towards in forward direction. So that's a way of writing vector B to A when you reverse the direction. And third representation is when you're more specific, when you want to know where exactly your vector is lying on x-axis or on y-axis. In that case, you can just write 1 comma 2. Suppose my vector is at 1 comma 2. So in matrix form, I will write a 1 above there and 2 down there. So this represents x direction and this represents y direction or y coordinate. So now let me move on to the types of vectors. So the first one is like vectors. There are two vectors. This and this, suppose A to B and C to D. They both have same value, A and A, magnitude, value, same. And you can see direction is also the same. So like vectors are vectors having same magnitude and same direction. So such vectors are known as like vectors. Second is unlike vectors. Now suppose vector is like this and this. It's A to B, its direction is this. C to D, its direction is this. Its magnitude is A and B. You can clearly see neither the magnitude is same in this case nor the direction is same. So I can say they both are unlike vectors, where vectors having different magnitude and different direction. Such vectors are called unlike vectors. Then there is a third kind of vector that is called negative vector, which is very important. When you will do the question, you need this one, so it's important. Negative vector. When two vectors are having same magnitude but directions are different, then they are known as negative vectors. So you can say having same magnitude but opposite direction. So suppose these are two vectors. A to B, and it's moving like this. Value is A. Then C to D, but the direction is just the opposite of A, and magnitude is A as well. In this case, magnitude is same, but direction is opposite. So I can write vector A to B is equals to negative of vector D to C. Because values are same, that's why you are equating. But negative signifies that they are opposite in direction. See, in general language, if I want to specify the direction, I will say east, west, north, south. But in mathematics, whenever I have to specify the direction of a vector, we use the negative or the positive sign. So negative sign signifies that it's moving backwards or in opposite direction. Say for example, you have studied acceleration in physics. So if it's acceleration, we use 2 meter per second squared. That means by 2 meter per second, every time the velocity is increasing, right? Every second velocity is increasing by 2 meter per second. That signifies acceleration. So you get to know that the car or your vehicle is increasing its speed. But if I'm writing negative 2 meter per second squared, this signifies deceleration or retardation. That means it is decreasing. Okay, now here the velocity is decreasing by every second with 2 meter per second. That is retardation. Okay, so this negative sign, and since it's a vector, for non-vectors we can't use. For weight, I can never use 5 kg or negative 5 kg because it's a scalar quantity. So I can never use negative sign. It's always positive. But acceleration, velocity, displacement, these all are vector quantities. So I'll use negative or positive sign to specify the particular thing. One more thing, this is very important. Everyone pay attention. Suppose this vector here, down there, A to B, its value is A. So what I'll write, vector A to B is A. But now they are asking what is vector B to A? What is vector B to A? Because we know magnitude, we know the value A to B is A. Now we have just reversed the direction. So this will become negative A. That's important. Is it clear to everyone? Write down yes or no in the chat section. Okay. So, which part is not clear? You can tell me. You want. I can repeat that. You can write that down or you can say negative vectors. Okay. See, negative vectors are simply those vectors that have same value, same magnitude, but their directions are different. You can take an example. Suppose there are two twins. Okay, this is 1 and this is 2, and they both weighs the same, like, or everything is same. Now this twin is at this end and this twin is at this end. Definitely the distance between both the twins are same. Now he is moving towards this direction and he is moving towards this direction. Obviously, if he is moving from here to here, if he is covering 220 meters, that means this, let me name it A and B. If B is moving 20 meters towards here, so that means A will also travel 20 meters. But they both are moving in opposite direction. So I will say that this value will be 20, whereas this value will be minus 20. Because they both are moving in different direction. That's why I'm signifying it with a negative direction, a negative value. But magnitude remains the same, so I'll still write 20. That's the meaning of negative vectors. When everything is same, only directions are opposite. Is it clear? And the same definition I've written here. Okay. And this thing also, I said that from A to B, if the value is A, right? Now I have reversed the direction. Value remains same when I reverse the direction. So I will write still A. A to B is still A, right? But on changing the direction, this will become negative A. So negative signifies that you have changed the direction. Okay, everyone, take the screenshot or note this down. Okay, now one thing you have to keep in mind whenever you will see a parallelogram. It's suppose A, B, C, D, and its value is given. Even a rhombus or parallelogram is given, and its value is given as A like this and B like this. So what does this mean? It means that opposite sides are always equal. We know that this is the property of a parallelogram where opposite sides are equal. In vectors, opposite sides as well as opposite direction is equal as well. So I will automatically write this one as B and this one as A. So in parallelogram, that's for vector, opposite sides are equal and their magnitude are equal as well. So simple direction, opposite side, that means opposite sides in terms of magnitude and direction are equal in vectors. So let me do one question. Suppose this is A, B, C, D, E, F. Its value is given as A. Its value is given as and direction is B, and this is given as C. Now what you have to do, you have to find all the other vectors. All the other vectors, that means you can clearly see this is D vector, D to B, B to E. So what all vectors I have to calculate? I have to calculate vector D to B, vector B to E, vector C to E, vector F to C, vector F to E. These five vectors I have to calculate. Now first thing is, the important thing is, there are parallelograms clearly I can see here. So this will give me a better idea how I can calculate this. This is clearly a parallelogram. If this is a parallelogram, easily I get to know that I told you opposite sides are equal in terms of magnitude as well as direction. So if it's moving towards this direction, that means D to E is this and the value is C. So D to E will be C. Then A to D vector. It's already given that A to D vector is A. That means opposite. I have to draw the same direction. So from clearly I can say vector F to E is also A. Let me know, is it clear till here, everyone? Write down yes or no. Just be quick. Okay. So if vector F to E is A, but what they are asking here, they are asking F to E, right? So we have calculated A. I'll write A. Now again, I have to see one by one. They are asking D to B. For D to B, I have to find another parallelogram. So I can see this parallelogram in this case, this one. It's moving in this direction, so definitely direction will be this. Value is B, so value is B. So D to B is B. We have calculated this as well. Now B to E. B to E. We know D to F is in this direction. So opposite is B to E because it's a parallelogram. This whole light green that I have drawn, D, B, E, F is a parallelogram where opposite sides are equal in magnitude as well as in direction. So if D to F is in this direction, that means clearly B to is in this direction. Value is already given B in the question. So I'll say this is B as well. If this is B, oh, I just realized this wasn't B, F to E, this was A. So F to E is A. In this way, D to B will also be A. Yeah, we just calculated F to E is A here, right? So opposite of D to B is F to E. So if F to E is A, that means D to B is A as well. So D to B is A. Now in the same parallelogram, D to F is B. So B to E will also be B. Now we have to calculate C to E. C to E, that means they are asking this one. So I have to look out for another parallelogram. Obviously, I can choose this parallelogram. Okay. I'm just doing what I'm doing. Maybe it is a little bit confusing, but what I'm doing, I'm just finding a parallelogram. Okay. If if I want to find E to C, so I'm looking for that parallelogram of which E to C is one of the side. So E to C is a side of which parallelogram? So I'm just writing E to C. It's better if I'll write it here so that you'll not get confused. E to C is a side of parallelogram DEFC. If it's DEFC, we know the property of parallelograms is opposite sides are equal. So D to F is in this direction. So E to C will be in this direction as well. So if D vector D to F is B, that means therefore vector E to C will also be B. Everyone, let me know, is this clear till here? Right, yes or no? Everyone, write down yes or no. If no, then I can repeat once again. But I want answer from everyone. Write yes or no. Okay, very good. So what I get to know that ultimately E to C is also B. But what they are asking, they are not asking E to C. They are asking C to E. So I told you if you have the magnitude, okay, Jasmine, you just let me know, Jasmine, write down which part you're not clear with it. So I can repeat it. So meanwhile, I'm just solving this one. So if vector E to C we have calculated as B, that means vector C to E will be opposite of it. And if it's opposite, so I will write negative B as my answer. Okay, is it clear to everyone so far? Okay, so just one. Okay, see, I'm just repeating the parallelogram concept. Parallelogram we use only to find the value. The most important thing that you have to keep in mind is that opposite sides of a parallelogram are equal in terms of magnitude as well as in terms of direction. They both are equal. That you have to keep in mind. So in this case, suppose I want to calculate vector C to E. I'm just focusing vector C to E, right? So I have to find a parallelogram of which C to E is a part. So definitely vector C to E, this one, this whole parallelogram DECF is a parallelogram of which vector E to C is a part. Why I'm finding parallelogram? So that I can easily find the value of the given vector. Clearly, we have to apply only this thing that opposite sides are equal. Okay, so that means I have to find the opposite side of E to C. Opposite side of E to C in this parallelogram, this pink parallelogram. The opposite side of vector E to C is B. They have already given in the question that vector D to F is in this direction and its value is B. Because the property is opposite sides are equal. So I can easily understand that if the direction of D to F is in this way, so E to C will be in this way as well. So I will easily draw this one. If the value of D to F is B, that means E to C is B as well. So it gives me a better idea or it helped me in finding E to C, which is B. But they're asking not E to C, they're asking C to E. We have calculated E to C, but we have to calculate C to E. So value remains same, but direction changed. That's why the value will be negative B. Now I have to look out F to C, right? So for F to C, this I'm talking about, F to C, this. In the same pink parallelogram that we were doing, we have another one. That means F to C. So D to E is given as C. That is given in the question. We haven't calculated it. That is already in the question. D to E is C. So opposite side of DE is, what is opposite side of DE is? Opposite side in the same parallelogram. Opposite side of vector D to E is vector F to C. So if direction is from D to E, obviously direction will be F to C. If value is C, this value will be C as well because opposite sides are equal. So I'll write this is C as well. So simply you have to find the parallelogram and find the opposite sides. If the opposite sides are known, just draw the direction as it is. Just write down the value as it is because opposite sides are equal in a parallelogram in terms of value as well as in terms of direction. Now note this down, everyone. Okay, now I'm giving one question. You all have to solve. It's almost same kind of question. It's A, B, C, D, E, F. This value is given as A, this value is C, and this value is given as B. Find vector A to F, vector A to E, vector F to B, vector E to D. Solve these four and write down your answer in chat section. Okay, now let me see one by one. So A to F. A to F, that means, okay, I got one another answer. So yes. So now if it's A to F we want to calculate, then we have to look out for what? The parallelogram. Parallelogram, that means I can pick this parallelogram. This one. Which parallelogram? A, F, D, E. In A, F, D, E, definitely opposite direction or opposite side is E to D. E to D, so same. E to D, I will make the same direction and same magnitude. So A to F will be C. Now A to E. A to E is this one. So opposite, which parallelogram I have to pick? A, F, D, E. Same parallelogram. But I should know what is F to D. So for that, for F to D, what I'll do, I'll pick another parallelogram, which is EFDC. A little bit of practice and it's very easy. You can easily solve it. So EFDC. In EFDC, opposite side of F to D is, opposite side of F to D is C to E. So I can say this will be D to F and value will be A. So I can say that if C to E is A, so F to D will be A as well. So F to D, D to F, sorry, D to F will be A. Now coming back to this parallelogram, AFDE. For AE we are saying. So D to F is A, that means E to A will be A. So E to A will be A. If E to A will be A, that means A to E will be negative A. Now for F to B. For F to B, I have to pick which parallelogram? F, B, D, E. In F, B, D, E, I can clearly see opposite side of F to B is E to D and E to D is C. If E to D is C, then clearly I can say F to B is C as well. So this is C as well. Last is B to D. B to D is a part of which parallelogram? E, F, B, D. Everyone just pay attention what I'm explaining. So it's a part of B to D is a part of F, B, D, E. D to B. So we have to find E to F. Opposite side is E to F. But unfortunately, we don't have E to F either. So for E to F, I have to find another parallelogram which is EFDC. 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 Opposite side is definitely CD. Opposite side is C to D. If opposite side is C to D, that means E to F is also equal to it and will be equal to B. So we have calculated E to F as B. Now coming back to this. If B to D opposite side is E to F, that means D to B will also be B. E to F is B, so D to B will also be B because opposite sides are equal in terms of magnitude and direction. But our question is B to D. So if D to B is B, then B to D will be negative B. So these are our final answers. We haven't calculated F to D, right? We have calculated D to F. So D to F will be A because C to E is A. So D to F will be A. Did I do any mistake, right? D to F is A, right? So F to D will be negative A. I think I missed writing F to D negative A, right? Yeah. C to E is A, so F to D will be negative A, right? Here it's negative A. I missed writing it. It's negative A. This was D to F, that was A, right? So F to D will be negative. So everyone note this down. See, uh, it's C to D already given as B, right? That's why E to F will be positive, not negative. Okay, that's given in the question, C to B as B. So opposite will be having same direction and same value. So that's why E to F will be B. Okay, everyone. Is there any question or doubt so far? Because I'm just moving on to the next part. Okay, now the next is the operations. The operations, that means when we use operators plus, minus, multiply, divide. So how can we do when we have to multiply a scalar with a vector? So simple, I'm writing it in a matrix form. Suppose my one vector is, say, A is 3 comma 2. If I'm writing vector A to B is A. But here in mathematics, I have specifically mentioned that this is 3 comma 2. So if 3 comma 2 and I want to calculate 2A, what will be the twice of this vector? So what I'm doing, I'm just multiplying. This is called multiplication of scalar and vector. So A is 3 comma 2. So twice of A will be 2 times A will be 2 times of 3 2. So I'll multiply 3 times 2 is 6 and 2 times 2 is 4. Multiply with every, right? Multiply with this as well. So this is your 2A. So you have to multiply with your x value as well as you have to multiply with y value. Similarly, if you are dividing a vector, that means same. If A is equals to 3, 2, then A by 2 will be what you are doing. Now you're dividing. So A by 2 will be 1 by 2 of 3 by 2, because you have divided a by 2, so you have to divide this whole by 2 as well. So answer will be 3 divided by 2 is 3 by 2 and 2 divided by 2 is 1. So it's simple, just how you multiply and divide the vectors. Same we do it here. Okay, is it clear? Now third is adding vectors. Adding vectors, that means if it's a vector is given as a is 2 over 3 and b is 4 over 5, and I have to calculate a plus b. So simple, what I'll do, I'll add 2 plus 4, 3 plus 5. Answer will be 6, 8. So a plus b will be 6, 8. And fourth one I'm writing here, I don't have much space, so I'm writing here. That is subtracting vectors. Subtracting vectors, so it will be a minus b. So if a is same 2 over 3 and b is same 5, 4, 5. So a minus b will be 2 minus 4, 3 minus 5, which comes out to be minus 2 and minus 2. So simple, just how you add, subtract, multiply, divide the numbers, same you have to do. On left hand side, I have multiplied scalars and vectors, divided scalars and vectors. On right hand side, I have added and subtracted vectors and vectors. See, division and multiplication of vectors and vectors doesn't work like this. How I added and subtracted. If it's like A, B, and if you're thinking you can do it like this, no. Multiplication is a little bit different. So only these four things we have to keep in mind. Multiplication, dividing, that is scalar and vector. And these are vectors and vectors. You are adding and subtracting vectors and vectors. Now just quickly take the screenshot of this. So now suppose I'm just deleting it. So now suppose A is given as 4, 5, B is given as 3 minus 2, and you have to calculate 2A plus 3B. So what you have to do is, first in place of A, the best way of solving is always try to go a little bit conventional. Don't try to solve just directly, because it will increase your chance of getting a wrong answer. So 2 in place of A, write 4, 5, and 3 in place of B, write 3 minus 2. Then first you have to multiply, obviously. So 2 times 4 is 8, 5 times 2 is 10, plus 3 times 3 is 9, and 3 times minus 2 is minus 6. Now you can add 9 plus 8 is 17, and 8, 10 minus 6 is 4. So this will be your final answer. Similarly, you can solve 2a minus 3b, 4a minus 7b, and so on. They can give you three vectors as well, like a is this, b is this, and c is this. And they will give you like this, solve 2a plus 3b minus 4c. But you always have to apply the same thing. Just quickly take the screenshot, then we'll do vector law of addition. Okay, now important, triangle law of addition or vector law of addition. You have to use this maximum number of time to solve. That means, like, if you will see the papers, you will see that you have to apply this law only to find the answer. And these type of questions you will find in 5 marks, 6 mark, 4 mark questions. So that's why this is very, very important. So as the name suggests, triangle law of addition, it has a triangle. And we use this to calculate the vector. If one vector is missing, we can use this. Just like previously, we were using parallelogram to find opposite side or something. Similarly, we have to see the triangles in order to find the third or the missing side. Suppose it's A, B, and C. Value of A to B is given as A. B to C is given as B. Now you have to calculate A to C. So according to the triangle of addition, it says the sum of two sides should be equal to third side in this case. But the direction matters the most. So you have to add those two. Obviously, sum of two sides equals to third side, but you should know which two sides you have to add. So those two sides you have to add whose direction are same. They are moving in same direction or simply following each other like this. There is no breakage. So third side should be opposite in direction. It can't be like this. This will become a cyclic because they are following each other and cycling won't work. Third side should have opposite direction. So in this way, I can say I can add those two sides that are following each other moving in same direction. So vector A to B plus vector B to C is equals to vector A to C because vector A to C is in opposite direction. Okay, just like you can clearly see it's opposite. So A to B is A, B to C is B. So vector A to C will be finally A plus B. Let me know. Is it clear? Everyone write down yes or no in chat section. Just quickly write down yes or no. Okay. Now, similarly, this question is given. Same triangle is given. And it's given as A, B, C. A to B is given as A. This direction they have already mentioned. And this direction they have already mentioned. And this is given as B. You have calculated B to C. You have to calculate B to C. Obviously, I have to look those two sides that are moving in same direction or following each other. Clearly, they are following each other. And this third side is opposite of it. So I can say vector A to B plus vector B to C is equals to vector A to C. The first thing is don't directly write A plus B. No. I always say go by the conventional method. Always a starting thing is write down what exactly is your triangle of addition and then put the values. Don't directly put the values and try to get the answer. So first I have to form the equation. So A to B plus B to C will give me A to C. A to B is A, B to C I don't know, and A to C is B. Now B to C will be B minus A. I'll transpose it there on right hand side and ultimately I'll get value B to C is B minus A. Just quickly take the screenshot of this one. Okay. Now I'm just giving one question. I'll send the recorded session on your email ID to everyone. Okay, so you can go through it once again. It will help you all. A, B, C. A to B, vector A to B is given as A, vector B to C is given as B, and you have to calculate vector C to A. So quickly, all of you give me the answer. Yes, very good. Most of you gave me the correct answer. That means first we have to apply the same triangle of addition. That two sides should follow each other, right? And third should be opposite. So that means when I apply the triangle of addition, I'll say vector A to B plus vector B to C is equals to vector A to C. Okay, don't write C to A here. Obviously, vector A to C. So vector A to C is A plus B. Now, according to the negative vectors, if you reverse the direction, so the sign changes, so it will become minus A plus B or minus A minus B. Very good, everyone. Okay, those who haven't they were not able to get it, just quickly take the screenshot and then I'll clear one more concept. Now see, suppose they have, you will find these questions. They will give some point. We have this triangle. Triangle A, B, C. It's given as that C to A is A to B is 2C, and there is a point here, suppose point M, and this point M has divided the vector C to B in ratio 1 ratio 3. So M is a point on vector C to B which has divided C to B in ratio 1 ratio 3. 1 ratio 3, that means this is one part. Obviously the smaller will be one part and the larger will be three part. If sometimes you got confused which one to write, one or three, so you can look out the diagram as well. It will give you a little bit idea. Else if they have mentioned C to B is 1 ratio 3, that means you are moving C to B, so 1 will come first, 3 will come after it. So in this way this M has divided this part. So first thing that we have to do is, now the question is they are asking calculate vector C to M. So C to M is a part of vector C to B. So the important part is first calculate C to B. If you don't know C to B there, you can't calculate C to M. Okay. If you're thinking that I'll make this a triangle, then at least for a triangle you should know two sides. Even for this triangle you have only one side, for this triangle you have only one side. This is the most common mistake done by a student. What they do, they just try to make triangles, but we choose only those triangles for which at least two sides are known. Then only you can calculate third side. If one side is known, two sides are unknown, how can you calculate the third side? And it's not possible at all. So for that, we first have to calculate this bigger side C to B, because the only triangle for which the two sides are known is triangle ABC. So I'm again repeating what triangle you have to calculate. You have to pick whose at least two sides are known. Okay. If you want to calculate C to B, you have to find that it's a part of which triangle and of which triangle whose two sides are known. Always go for this one. So in triangle ABC, the same thing I'll apply. That means two sides are moving in same direction. So C to A to B. They are moving in same direction. So I'll write C to A plus A to B equals to the side which is moving in opposite direction. So I'll say vector C to B. So C to A is A to B is 2C. So I can easily calculate vector C to B is A plus 2C. Now I want to calculate C to M. This is important. They have given us the ratio. The simplest way, I can give you a whole conventional way of doing it as well, but there is no point of going there. A short trick of converting a ratio into a proportion is simple. This is one part. Out of how many parts? 1 plus 3. So this is 1/4. This is 3 part. 3 of how many parts? 3 plus 1. That is 3 by 4. So I can say CM, vector C to M is 1/4 of which? The whole C to B. This is how we can convert a ratio into a fraction or into a proportion. If ratio is given and I want to know how many part of something is this. So this is a way by which you can convert it. Similarly, vector M to B will be 3 by 4th of whole big C to B. Let me know, this part clear to you, all of you, or not? Just write yes or no in the chat section. Be quick. Yes, so I'm just repeating this once again. if C to M is one part, right? So what I'll do, C to M, I'm writing down here. This is very important. So C to M is what? It's one part out of which two parts? The ratios are given in two parts, 1 and 3. So out of 1 plus 3, because C to M is what? 1. So C to M 1 by 3 of bigger C to B. That's important. The bigger side. Because M is a point on C to B. So M is a point that is dividing C to B. So C to B is the most important and the bigger side. So Cm will be 1 over 1 plus 3 of C to B, which is 1 by 4 C to B. Then M to B. Actually what they are given, 1 ratio 3 is given as C to M ratio M to B. Right? So this is 1 ratio 3. So Cm is 1 out of 3 plus 1, 4. So C vector C to M is 1/4 of C to B. M to B. M to B is how many parts given? It's 3 parts. 3 out of 3 plus 1, 4 of C to B because M is dividing C to B. So now we have two equations, these. C to M is 1/4 of C to B and M to B is 3/4 of C to B. So since we have already calculated C to B and what we want to calculate, C to M. So C to M is 1/4 of C to B. C to B is what? A plus 2C. So A plus 2C. So C to M will be finally 1 by 4th of A plus 2C. In this way, we can calculate when it's given as there is a point which is dividing something or something like that. Okay. Now just quickly write this down. Everyone, take the screenshot and I'll give one question. Okay, let me share one question. Okay, try to solve this if it's okay. I think you can read it now. Draw this triangle in your copy as well because there are other parts as well and I have to change the slides. So quickly roughly draw this one and then solve 1a. Everyone just be quick, try to give the answer. See, it says write the vector ML in terms of A, B. ML, that means which vector they are asking? This whole ML. Same, I have to apply triangle law of addition. Which two are following? If ML, the first thing is if in the diagram they haven't specified the direction, so draw it. They are asking M to L, that means they are asking this one. Which two sides I have to add? Those two that are moving in same direction or following each other. And ML is just opposite. So I can say M to K plus K to L is equals to M to L. This will be 2A plus B will be M to L. So final answer is 2A plus. So yes, Sarah, your answer is correct. Okay, now solve 1B and 1C. I hope you have drawn the triangle. Yes, C. Since you have already calculated M to L, which is 2A plus B. I'm going a little faster because the class is about to end. So M to L will be 2A plus B. Now what they are asking M to P, and what they have mentioned that point P is halfway along M to L. That means it's just the half of it. If 2A plus B is ML, then half of ML will be MP. MP will be half of ML because it's a halfway. So I can easily say M to P will be 2A plus P over 2. That will be your final answer. Now the third one, I'm doing it. It says a new point N is to right of L. Mn is 4 times. So what they have mentioned, a new point N is right of L. Mn is 4 times the length of MP. So Mn is what? 4 times length of MP. Whatever the question is given, try to decipher or try to write in a mathematical form. Convert the sentences into mathematical format. So Mn is 4 times length of Ml. So Ml will be 4 times MP. Now write down Mn in terms of A and B. Okay. So it's Mn written, right? Sorry, not Mn. It's Mn. So Mn is 4 times the MP. Now it says N is right of L. So somewhere N is here. We don't know where it is, but right of L. And Mn is 4 times MP. So Mn is, that means this whole. This whole is 4 times MP. MP we have calculated 2A plus B by 2. So M to N will be 4 times MP. That means 4 times 2A plus B by 2, which is 2 times 2A plus B or 4A plus 2B. is your final answer. Now, everyone, let me know, is it clear? Yes or no? Just quickly write yes or no in the chat section. Okay, so this was the basic of vectors that is required to do all the type of questions that is being asked in the exam. You have to practice the questions. So what I'll do after this class, I'm just about to end. So what I'm doing is I'll share you this recorded session. Okay, so you can go through it, and also I'll share the worksheet so you have to practice and along with the solution so that you can see it. It will help you in finding the answers or clearing your doubts. So basically that's it for today, and I hope you enjoyed the class. Okay, and if you will have any doubt or something, you can communicate with me via email. You have my email ID. So okay then, thank you. Bye everyone, take care.